Okay, so we're looking at the applications of trigonometry, what you would use trigonometry for. Okay, so in Year 9, the only applications that we need to look at are angles of elevation and angles of depression. So when we're looking at elevation, we're looking up. So this is angles of elevation and depression. So when you're looking up, you're looking at angles of elevation, and when you're looking down, you're looking at angles of depression. So copy that down, and when you're ready, come to the next slide. So here's the diagram. So normally the ground is where you're starting from because you're the person at the ground, and you're looking up. For instance, you might be looking at the sun. Okay, so you're looking up to the sun, so that angle in there is called the angle of elevation. With this one here, normally you'll be standing somewhere on the ground, maybe on the top of a cliff, and you're looking down to something, so that would be the angle of depression in that position. So it's looking down. So you're looking straight ahead, and then you look down. Whereas the other one is you're looking straight ahead, and then you look up. So copy those down, and then let's have a look at some examples. So here's a diagram. Obviously in Year 9, all the trigonometry is right angle trigonometry, so all of these questions will involve a right angle triangle. It's a matter of putting the numbers in the right position. So for instance, if the angle of elevation of the sun is 15 degrees, you're down on the ground, and so looking up is 15 degrees up to the sun. And for instance, the angle of depression to a boat, like for instance you're at the top of a cliff. Okay, so you're standing at the top of a cliff. Okay, then you're looking down to the boat, which is in the ocean. So you're looking down, the angle is 47 in that top corner. Okay, so let's look at some numbers. So using trig to solve problems. Okay, so we've got a 12-metre tree making a 2-metre shadow. So you've got to remember that shadows always lie on the ground, and we have to assume that the ground is flat. The ground is flat. And that the tree goes straight up. Okay, so looking at the numbers, we've got a right angle triangle in the corner, there's a 12-metre tree, and there's a 2-metre shadow. So basically label the sides. So we've got the hypotenuse, we've got the opposite, and the last side is the adjacent. So looking at the ratios, if we don't have the adjacent, we can't use cos and we can't use tan, so we're looking at the sine. So the sine ratio is sine theta equals the opposite over the adjacent. I've just made a mistake, so let's just go back all of that way. So hang on. So we do have the adjacent, we don't have the hypotenuse, so we can't use sine and we can't use cos. So sorry for that. So we have tan theta, my apologies again, tan theta equals 12 over 2, so theta equals tan minus 1, 12 over 2, which is equal to 6, so just need to put 6 equals, and then just use your calculator. So we have shift tan 6 equals, so it's 80.5 degrees. And if you wanted to do minutes and seconds, like we did in last class, 80 degrees, 32 minutes, and 15.6 seconds. So sorry again, it was a tan question, not a sine or cos question, so apologies for that one. Okay, copy that down. When you're ready, come to the next slide. Okay, so looking at the next one, a boat out at sea. So for instance, there's the sea down the bottom, there's the 2,000 metres, there's my right angle. The person sees the boat at an angle of depression of 10 degrees, and the question is, how high is the cliff? So you can call that any letter. Now, you've got two choices. At this stage, the easiest choice is just transfer the numbers. So that 2,000 can come up to there, and that x can come across to there, and the right angle is in that corner there. So there's nothing on the hypotenuse. Okay, x is the opposite, and then that's the adjacent. So car, toa. There's nothing on the hypotenuse, so we can't use sine, we can't use cos, so we have to use tan. So this time tan of 10 degrees equals the opposite over the adjacent. Now x is on top, so therefore it's a multiply. So the next line would be, therefore x equals 2000 times tan 10. I'm hoping this is going to give a sensible answer, not too high. Times tan 10. So the cliff is very high, 352.65 meters. Okay? I say to whole numbers. So on that previous question, we probably should finish with a word, therefore angle of elevation of sun is approximately 81 degrees. So if it's a word question, try to finish with a word statement. Okay, so in the book there'll be some questions to do with angles of elevation and depression. If not, we'll put up a worksheet. Okay, thanks for that. Bye.